The technology relied on a spectrometer, a device for breaking up light from a distant source into its multitude of components, essentially a very scientific rainbow. With that spectrum, astronomers like Mayer and Claus could find the signatures of known elements, like hydrogen and carbon, from the fingerprints they leave in the spectrum. From there, they could stare at the star day after day, looking for changes in the spectrum. And those changes in the spectrum could reveal the movement of the star through the Doppler shift. The same shift that causes the wail of an ambulance to change pitch as it passes by you happens to light. When a source is moving towards you, the light gets shifted towards higher, bluer frequencies, and when a source is moving away from you, it goes down to lower, redder frequencies. This was not a new technique. Astronomers have been measuring the Doppler shift of stars for almost 200 years. But in 1995 Mayer and Claus took it one step further, upping the precision of their instrument to new levels, staying on the lookout for even the most minute changes. If a planet is orbiting a star, the gravity from that planet will pull on the star like a leash on a stubborn dog. The star won't move a lot. Stars usually outweigh their planets by several orders of magnitude, but they'll still move, hopefully in a detectable way. And in 1995 the pair of future Nobel winners nailed it, confirming the unmistakable back-and-forth wobble in the spectrum of the star 51 Pegasi, a wobble that could only be caused by a relatively small, unseen companion and exoplanet in orbit. There's nothing particularly remarkable about 51 Pegasi, and that's what makes the discovery of an exoplanet there so remarkable. It's just a normal, everyday run-of-the-mill star, sitting about 50 light-years away, with a mass about 10% more than the Sun and an age just a tad higher, at 6 billion years old. It's a normal star, living a normal stellar life, with at least one planet in orbit around it. Just like our Sun. The discovery by Mayer and Claus ushered in a new age of exoplanet hunting, leading to hundreds, and eventually thousands, of confirmed exoplanet detections. They're so commonplace now that announcements rarely even break into the news, and it's only a matter of time before we find an Earth-like twin. But the planet orbiting 51 Pegasi is nothing like what we see in our solar system, and it was so surprising that one of the first reactions to its discovery was to toss out the result altogether as junk. But the result of Mayer and Claus was indisputable, and we had to confront the reality that 51 Pegasi presented us. Its planet, dubbed at the time 51 Pegasi b and now given the name Dimidium by the International Astronomical Union, though some astronomers cling to its informal name of Bellerophon, is a pretty typical gas giant, about half the mass of Jupiter, or 150 times the mass of the Earth. And it orbits a mere 5 million miles, 8 million kilometers, away from its parent star. For context, that's more than 7 times closer than Mercury is to our Sun. How did a massive gas giant, which can only form in the outskirts of a solar system where there's enough raw material to bulk a planet up to such massive proportions, wind up so uncomfortably close to its parent? We're still not exactly sure, but we did come up with a cool name for them, hot Jupiters. With one dedicated observation, Mayer and Claus pulled off 2 tricks. They launched a new era of astronomy research in exoplanets, and they appended decades of understanding of how planets form. No wonder they won a Nobel Prize.